Good morning, children. So today we are going to continue the history of periodic table. We have already discussed Dobereiner's triads and also Newland's octaves. Today we are going to discuss Mendeleev's periodic table, which was a very important step towards modern periodic table. So let's start with Mendeleev's periodic table. So when Mendeleev started his work, only 63 elements were discovered, okay? And he was looking the relation between the atomic mass of an element and their physical and chemical properties, okay? So he was just checking the connection between atomic mass and their properties. What properties? Physical and chemical properties, okay? Now we know that atomic mass is the mass of one atom of an element. For example, atomic mass of hydrogen is 1 AMU, atomic mass of oxygen is 16 AMU, atomic mass of carbon is 12 AMU, so on we have learned in class 9th. So atomic mass is mass of one atom of an element. Okay. Now, what do we understand by physical properties? Physical properties are properties such as density, boiling point, melting point, even color, shape, etc. are called physical properties. Now chemical properties means the chemical reaction of these elements, right? But he checked the reactivity of elements with hydrogen and oxygen only, okay? And to form hydrides and oxides. He selected oxygen and hydrogen as they are very reactive and form compounds with most of these elements, okay? Now one more time. He checked the connection between atomic mass and physical and chemical properties. Okay. Under chemical properties, he checked how these elements react with hydrogen and also with oxygen to form hydrides and oxides. For example, sodium reacts with hydrogen to form sodium hydride, chemical formula NaH. Similarly, potassium reacts with hydrogen to form potassium hydride, KH. Okay. And in the same way, sodium reacts with oxygen to form sodium oxide, Na2O, and potassium with oxygen to form K2O. Okay. Generally, if we consider these type of elements as R, letter R, okay, with hydrogen, they will make RH, hydride, like NaH, KH, etc. And with oxygen they make R2O like Na2O, K2O, etc. Okay. And the elements form hydrides and oxides in this way. This same chemical formula, he found that they can be grouped together. Okay. And Mendeleev used the formula of oxides and hydrides in his periodic table. Let's check what is that. See here, this is Mendeleev's periodic table. You can see the chemical formula of oxides and hydrides of the elements. See, for the first column, this is the first column, okay. All the elements form oxides as in the general formula R2O and hydrides as in the general formula RH, okay. And second column, for example, this column, okay, second column, all elements form oxides using the formula RO, for example, calcium oxide, CaO, and hydrides in the formula RH2. Alright, so using this chemical formula, the elements which making the same general formula he grouped together. When elements are arranged or grouped in this way, Mendeleev observed repetition in physical and chemical properties of these elements. He also observed that elements are now in the order of increasing atomic mass. Right? So he arranged the elements in the increasing atomic mass as well as according to the repetition of their physical and chemical properties. So based on all these facts, Mendeleev put forward a periodic law which states that the properties of elements are periodic functions of their atomic masses. Periodic function means they will be repeated at a regular interval. Okay. So Mendeleev stated that the properties of elements are periodic functions of their atomic masses. Okay. I hope it's clear to you. So we are moving to the advantages of or the merits of Mendeleev's periodic table. Here are the achievements of Mendeleev's periodic table. Let's check one by one. So the first one is Mendeleev predicted the existence of some elements and put gaps in periodic table for those elements. You can see some gaps are put in his periodic table. See here, for example, here below aluminium, below boron, one below silicon, etc. are gaps, isn't it? So for example, the element just below aluminium, this element was predicted as Eka aluminium. Eka is a Sanskrit word meaning one. Okay. So Eka aluminium, and he predicted all the properties of that element. So years later, when a new element, gallium, was discovered, the properties were almost as the Mendeleev's prediction. Okay, quite amazing, right? So similarly, he predicted one element which comes below boron as Eka boron, and one element under silicon as Eka silicon. And he predicted all the properties of Eka boron, Eka aluminium, and also Eka silicon. Eka boron was replaced by scandium after many years, and Eka silicon by germanium. Okay, and the properties of Mendeleev's prediction was almost same as the discovered elements. The second achievement of Mendeleev's periodic table is, in some cases, the increasing order of atomic masses cannot be maintained. Okay, he did this to group the similar elements together. For example, if you take cobalt and nickel, you can see cobalt is slightly heavier than nickel, isn't it? Cobalt is having more atomic mass compared with nickel. So cobalt actually should be placed after nickel, right? But the properties of cobalt is similar to rhodium, and the properties of nickel was similar to palladium. Okay, that is why he grouped these elements together irrespective of considering their atomic masses. Okay, next achievement was noble gases were not discovered at the time of Mendeleev's periodic table. But when they were discovered, they could be placed as a new group without disturbing the whole structure. I mean, without disturbing the existing order. Okay. Scientists could place noble gases as a separate group when they were discovered. That was another advantage of Mendeleev's periodic table. He introduced groups and periods. Okay. Now in this periodic table, you can see 8 groups are there. These are called groups. The vertical columns are called groups. Okay. This is the first group, second group, third group, and so on. 8 groups are there total. And the horizontal rows are called periods. Okay. See here, 6 periods are there in his periodic table. This is the last period. Okay. The vertical columns are called groups and the horizontal rows are called periods. Mendeleev is the scientist who put the basic structure for modern periodic table. Therefore, Mendeleev is known as the father of periodic table. Now let's discuss the limitations of Mendeleev's periodic table. There are mainly 3 limitations were there for Mendeleev's periodic table. The first one is, we know hydrogen. Hydrogen, atomic number 1, it resembles first group elements as it has only one electron in the last shell. First group elements are called alkali metals. And hydrogen is also resembles with halogens. Halogens means 17th group elements in modern periodic table. Now like alkali metals, hydrogen combines with halogens, oxygen and sulfur to form compounds. Alkali metals are combining with oxygen, halogens and sulfur to form their own compounds. Similarly, hydrogen also combines with halogens, oxygen and sulfur. For example, hydrogen combines with chlorine to form hydrogen chloride. Hydrogen combines with oxygen to form water. Okay, exactly like how alkali metals are combining with these elements. Okay, and they also behave in the same way how halogens are behaving. For example, hydrogen is existing as a diatomic molecule H2, similar to halogens, where halogens are existing like Cl2, Br2, I2, etc. Due to these resemblance, Mendeleev failed to assign a correct position for hydrogen. That was the first limitation of Mendeleev's periodic table. The second one is the case of isotopes, which is very important. We know that isotopes are atoms of same element having same atomic number but with different mass numbers. As their mass number is different, as the number of neutrons are different in these isotopes, what happens? The isotopes of an element is having different atomic masses. Are you getting? Therefore, if the elements are arranged according to the atomic masses, each and every isotope should have its own position in the periodic table. Okay? But Mendeleev did not address isotopes. He didn't say anything about the case of isotopes. And the third limitation is, the atomic masses do not increase in a regular manner going from one element to the next. So it is not possible to predict how many elements would be discovered in future. That means from one element to the next element, the atomic mass does not have any regular increment, right? So we cannot predict how many elements would be discovered in future in between these two elements. Okay, today we discussed about Mendeleev's periodic table. What is Mendeleev's periodic table? What are Mendeleev's periodic law? The achievements and the limitations of Mendeleev's periodic table. Okay, now correcting all the limitations of Mendeleev's periodic table, modern periodic table has arrived. So in the next class we are going to learn about modern periodic table, the introduction of modern periodic table. Hope today's class is clear to you. We'll meet you again in the coming class. Take care and bye-bye.